probably less than that. So it is very, very long half-lives, and therefore the concentrations on Earth
Okay, anyone from FIPI, can you please confirm if my audio is visible? Audio is audible.
Yes, sir, your audio is audible.
Okay, great. Thank you.
We'll be waiting for a few more minutes and then we'll be starting.
Sure, sure, sure. Mhm.
I think we'll wait for 2-3 more minutes and then we'll start off because network issues might be there for a lot of people. People are joining in.
Okay. Okay, so am I audible?
Yes, you are
Yes, yes.
audible to me.
Okay. So, good evening, everyone. I am Setu Patel, and on behalf of FIPI PDPU student chapter, I would like to invite all of you to the workshop. I'm genuinely overwhelmed by the response that we have received this time. FIPI is a healthy and strong interface between the government, legislative agencies, and regulatory bodies. It is a synergized society that takes India's oil and gas sector to newer heights of professional excellence. Now, FIPI PDPO is a student driven organization that aims at organizing guest lectures, conferences, technical fests, and other events for budding petroleum engineers, mostly focusing on the petroleum industry. I feel pride as I see that we recently had our annual FIPI convention where we won the award for the Best Student Chapter 2019. I request everyone to mute their mics to avoid unnecessary disturbance. Okay. Now, in 2006, Clive Humby quoted, "Data is the new oil. Like oil, data is valuable, but if unrefined, it cannot really be used. Data must be broken down and analyzed for it to have value. Using data and models in the petroleum industry, we can optimize well control and placement, optimize producing rates, design pressure maintenance, and fine tune the production forecast. Which is why we all have gathered here to learn about the reservoir stimulation using Python and machine learning in petroleum industry. Reservoir simulation is the use of computer model of the reservoir and real-time field data to predict and analyze the future behavior of the reservoir. I would like to welcome our today's speaker, Mr. Divyanshu Vyas, reservoir stimulation intern at Reslitics, founder of Petroleum from scratch. He got an All India rank of 17 in the GATE 2020. I feel immense pride as I say that he is an alumnus of the 2014-2018 batch of BTech Petroleum Engineering PDPU. I'm glad that we have with us here today Dr. R.K. Veech, Director SPT PDPU. He has 35 plus years of experience in the oil and gas industry. Sir, if you would like to say a few words. Do we have you with us, Veej, sir, in the meeting?
Hello, am I audible, Setu?
Yes.
Yes, sir.
Yes.
Yes, sir.
Yeah.
Yes.
Good evening, students, and my dear Divanshu Vyas. I don't know whether we met or not, but it's really a great moment for all of us in PDPU and all of petroleum engineers that you are sparing time out of your schedule for this course. And it's a very important course, reservoir simulation. As I have seen in the industry, most of the decisions are taken based on the simulation studies and forecast only. And you have added to it in machine learning, which is also a good thing. And as per my experience, that in our oil industry, we are not equipped with this machine learning and data analytics, Internet of Things, as others IT industries are. So I hope that you are mixing simulations along with this. So this will definitely help us and will give a broader idea to all the students as well as the petroleum engineers. And it's a need of the hour that in oil industry we should start using machine learning and integration of the Internet of Things and data analytics, etc. And congratulations that you scored as Setu told that you got a 20 rank. And most probably, I don't know whether you are joining ONGC or industry or not, but still it's good whether you join industry or you are you are doing your own startup or other business. So we need people like you, young people, because there is a really lack of young professionals in oil industry. Although the older generations like us, we have retired and new people have joined. So your this 3-day talk will go in a long way in training our petroleum engineer, and they will give really insight into the simulation. And for your information, in PPU, I don't know whether you pass out at that time, what was the situation, but today, Divanshu, we have 30 licenses of CMG IMAX, we have Petrol, we have T-Navigator, all the licenses, Kappa, and most of the Frac Pro, most of the software licenses we are having. We are giving training to our students on this software. Last year also, we have trained our students in Petrol and CMG. This year again, we are planning for the CMG training as well as the Petrol for reservoir simulation for static model, dynamic model, and other things also. So I hope that your lecture will go in a big way for giving knowledge to. And I'm thankful to my FIPI colleagues. They always take initiatives, and as Setu told that they were the best and they will remain the best. And thank you for the FIPI executive, new executive, who have gathered our alumni, all the alumni. And Divanshu, whenever you are getting chance after COVID, visit PDPU. We will welcome you there in PDPU as and when this COVID will be there. And again, once again, I'm thankful that you are sparing time for sharing your knowledge and disseminating the knowledge which you have acquired in maybe in last 6 years. Thank you, Setu. Thank you very much. Another the executive of the FIPI, and I hope that all of you should get a good knowledge in. It's a 1-hour session, Setu, or how much duration? Duration
Mr.
plus.
Divyanshu Vyas, can you?
Yes, sir. Sir, it's good evening, sir. Divyanshu, and it's an immense honor to have you with us. And I've been following you on LinkedIn, and I felt like I was like I should have been there one more year so that I could have met you. I just passed out and you joined PDPU. So it's a great honor, sir. Great honor.
Yeah, good, Devanshu. We need people like you. See that PDPU. I am telling again and again that PDPU have a great potential. You all have good potential, like other petroleum engineering institutes. And only thing is that you should work together, like you are sparing time. It's a good thing that these things we should have. Whether you are disseminating knowledge between the PDPU, I want that everybody, like whether it's ISM fellow or MIT fellow or UPS fellow. So you should coordinate among yourself and get knowledge, because this petroleum engineering is such a knowledge that it's changing every day. It's technology driven and all that. So maybe that nobody had talk on this reservoir simulation using Python machine learning for a few years back, but now it's a hot topic. And I'm good that you are choosing this topic, and you will share your knowledge with them. So really, I'm happy that you are here. And whenever COVID is over, so you are stationed in Ahmedabad or somewhere else? Where you are stationed?
I'm in Rajasthan, sir, and I'm yes, sir. Right now in Rajasthan.
So whenever this COVID will be over, so whether you join ONGC or before join or even after joining ONGC and other company industry, you should visit PDPU. Okay,
Definitely.
Always welcome. Okay, thank you, Setu. You can go ahead. Okay.
Yes, yes.
Thank
you,
sir.
and all the participants also that showing enthusiasm in that, and you should ask question to him also, and you should get your knowledge refreshed also. It's a really a good thing. Thank you very much.
Yes, yes. Thank you, sir.
Thanks a lot, sir. Thanks a lot.
I think it's a really big deal to have achieved so much at such a young age. Now, moving on with the workshop. About the workshop, it's going to be a 3-day workshop with one session for each day. The last session will be followed by a quiz where the top 3 contestants will be given a winner's certificate. An e-certificate will be provided through your registered email ID if you mark your presence on 3 days along with the final quiz. Now, I request everyone to please keep the mic muted to avoid unnecessary disturbance. If in case you have any doubts, then you can raise your hand and we will unmute you. And also, if you want to, then you can also write it in your chat box. Now, without further ado, I would like to request Mr. Divyanshu Vyas to share his cognizance with us.
Okay, so am I audible?
Yes, yes, you are. It to your registered email ID if you mark your present.
Okay. So I'll share my screen now. Please let me know if it is visible. Okay. Okay. Is it visible?
Yes.
Yes, sir.
Yes.
Yes.
It is visible, right? Okay. Okay, so welcome everyone. You already know me by now, and we've had a good, real detailed introduction about this session, which I could not have done. And this is something about me. I have passed out from PDPU in 2018 as a petroleum engineer, and right now I'm a master's student at Indian Institute of Technology, ISM Dhanbad. I'm also working with Reservoir as a reservoir simulation intern, and I'm really excited to work for them, and I'm learning a lot of new things. I recently started a venture of my own. It's called Petroleum from Scratch. I have a team of 4 people with me. They are my brothers, and we're trying to revise things that we have learned, and we're trying to bring forward those things. Okay, so let's get to serious talking, and let's not have any TED talk from my side. I'll try to cover a lot of things in this mini course about reservoir simulation, about Python, about various aspects of computer programming. But I'll not sound like a very, very deep programming guy or something like that. I'll try to sound very practical. I'll try to bring forward things that are actually important. You'll attend courses and you'll feel like, okay, do I need this? Okay, so this is the course where you will get to know things that you will be needing in your petroleum engineering models, and you will be developing a versatile knowledge. Python is a good tool to have because, talking about reservoir simulation, yes, it's a great honor that good colleges and a lot of colleges have the licenses on CMG and Petrol and Eclipse. These are the commercial simulators. But the problem is when you'll go and first sit on the softwares, you'll feel like you're in a black box. You're just clicking buttons, and it's important to understand the workflow. And this is exactly what I'll be trying to bring forward. The show will this mini course will try to bring forward the various kind of small workflows that if you bring together, you'll be trying to build a simulator of yourself, right? So the interface that I'm using for this presentation, you can see that it's not a presentation. It's called a Google Colab notebook. Okay, so if I'll share this notebook with you for your reference by the end of this session, and you can directly click on this and you start coding right away. You don't have to download anything and all. You just have to go to your browser and just get to this notebook. So this reduces your effort and time and all. So you start with Google Notebook. It gives you a lot of RAM and a lot of fast computing space, and you can start away. Just an introduction. If you type something in a command and you want to run it, you just type Shift plus Enter and you can run it. Okay. Rest you can Google it up. That's the very important skill. All right. So we'll start with Python from not even zero. We'll start with Python from below zero. We'll be talking about things. This is a very good session for people who know about Python. It's a very refreshing and a revision kind of thing. But for people who have no idea about what Python is and what is this thing, but have interest in developing some base on Python, I hope this helps you. Okay, so let's imagine that Python will ultimately be dealing with data, right? So let's imagine you want to store some number in some variable. So you have a variable name and you store that number. You can imagine it like you have a box and then you store that some number in that box, right? Or some name in that box or some sentence in that box. Anything can be stored in a box, and that box is called a variable. It can have a name, it can have a label, it can be called X, Y, Z. It has an address in programming space, which you don't have to worry about, right? So these are called variables. Now, what if you want to store not just one value, but 5 different values, 10 different values? Python allows you to do that using lists. You want to store your name, your address, you want to store your email ID, your bank account number, and all that stuff. You want to store all these different kind of things. You can store them in lists. Okay. There are other containers as well. I call them containers. Containers like tuples and sets. Tuples are very useful in cases where you want to keep your data secured, right? Tuples don't do. On list you can change at the end. Like I specify a list and I can change the list in the future as well. But tuples, once I specify, if you try to change a tuple, the computer will get angry, right? So you cannot change tuples. So if you want to dig into these things, and I've provided this very brilliant link to you, w3schools.com. This will take you directly to the information about tuples. I'll be covering, like I said, I'll be covering very important thing for petroleum engineers, right? And this is my favorite kind of data structure. In this, in list, the problem is, for example, you want to store porosities and you want to store permeabilities, right? So looking at if someone, let's say Setu, looks at my code and I ask her to interpret what is it, will she get to know that this is porosity and this is permeability? No, right? So this is where dictionaries come in. You can give the keyword, which is porosity, then store the list of porosities, comma, you can give keyword permeability, which stores a list of permeabilities, and then you can enclose these things into curly braces. This makes a dictionary. Simple, right? Now Setu can look at it and be like, okay, this is porosity, this is permeability. The advantage, however, lies in the fact that this dictionary can be directly converted to a table, which will be covering. In Python, the table is called a data frame, okay, which we'll be covering later. Right. So if you want to store the variables with a name, there are certain rules. Not a lot of rules, but there are certain rules. You cannot start with a number. Okay, that's the very important rule. Otherwise, you'll be like, okay. Otherwise, you'll never feel like error, this kind of error. But this, if I try to run this, yeah, you can see that it says that it is invalid. Okay. It says that the token is invalid. However, if I try to comment it out, you can comment it by putting hash at the front. Okay. Now, if I try to run bond 007 equals to 5, now you can see that there is no error. Why? Because I'm starting with the letter. Okay. So this is a very basic thing to remember. Ultimately, if you don't remember, don't worry. Just give your variable name as characters. That's it. Okay. Not spatial, but just letters, right? This is called initialization. Like I said, we are taking 5, putting it into a box. The box is known as bond 007, or the box is known as X. The box is known as Y. The box is known as name, and this is my name. All right. So now let's look at how we can do various things with Python. For example, if I want to print something, this is where Python is very beautiful. You want to print something, the print command helps you. Just an example, if anyone's come across C++, the print command is not print command. You use cout, C-O-U-T. Do you get any clue from cout? No, you don't. That is why Python is brilliant, because print is print. Okay. Now, this is very simple thing. This is if you put /n in between your string which you are trying to print, what you will see is, I'll try to run it. Okay. I'll try to run. I press Shift plus Enter. You can see that in this I didn't provide any /n in between, so it printed in one line. In this I provided a /n in between. It cut the line where /n was there and printed girls on the next line. Okay, so you can see hello guys was printed in one line. Hello girls, next line, right? So this is introduction to print statement. Now it's a very important thing. Someone on LinkedIn also asked me this question, that what is this F thing that you use in your codes? Okay, so the F thing is nothing but, you know, a case where you want to display a statement along with the variable, and you'll get a lot of cases like these, right? You want to print the porosity of my rock is equals to porosity, but the porosity is stored in a variable. So if I don't use this F and I just print this right away, it will print X plus Y. I can try that out for you. For example, I go to this code cell. So let's say print value equals X plus Y. Okay. So you see, this is what gets printed out exactly like I specified in the print statement. However, just by adding this F at the front, the difference I get to know is, I run this, you can see that the difference is this statement I'm talking about, statement number 0. This is X and this is Y, where this is called the placeholder. In place of, wherever this curly braces are there, the value of X will be printed, not the entire, the picture of this. The value of Y will be printed, not the exact version of this. Okay, so you can see this is X and I gave this, but the value printed is this. I gave Y, the value printed is this. Okay, so I hope it's clear. F string, these are called formatted strings or F strings. Okay, you can do various things and you can play around with this. And yeah, this is very important. In mathematics, every one of you knows BOD-MAS, right? There's a set of precedents the operators follow when you're trying to manipulate something. A lot of courses on Python will talk 2 lectures about BOD-MAS, right? But what I will advise is, separate your clusters, put them in brackets, move ahead. That's it. You don't have to worry about BOD-MAS at all. For example, I want X plus Y to be calculated separately, X minus Y to be calculated separately, and this quadratic to be calculated separately. I put them in brackets. That's it. Once you put things in brackets, BOD-MAS is no longer active, man. It's very simple. You can just go on and build your own BOD-MAS, right? So this is something about print statement. Let's move forward. For example, now that you know, okay, I'll write this down for you. So if you want to multiply, this is something you use, X multiplied by Y. Okay. If you want to add, you use X plus Y. If you want to subtract, you use X minus Y. If you want to build something to its power, X square. So this is how you use 2 asterisks. It is unique in Python. You use 2 stars. Okay. And yeah. So these are, and if you want to find out the remainder of something, for example, if I divide 5 by 2, you can use the modulus operator, right? So these are the few things that you can keep in mind about operations, the mathematical operations. Moving ahead, okay. For example, if you want to apply this into a simple code and you want to calculate the pressure at a particular depth, which is 5,000 feet, of a column of mud sample, which is 15 ppg, petroleum engineers will shout out the formula and be like, okay, it's 0.052 rho into depth, and you will bring out your Casio calculators and solve it. You can do that same thing in Python, and this is how you do it. And this is how you use the f string. So this is a revision of what we have learned by now, rho into d. This is how you multiply. Moving ahead. So this is one kind of manipulation. What if we want to compare and contrast between various values? You want to check for equality. You want to check for inequality. So these are the examples. For example, I want to check if x is equals to y. Let's see what x and y are. X is 5 and y is 3. So if I check for equality, equality is tested by double equals to sign. Okay. So if I check for x, is x equals, when you are reading this, you read it like, is x equal to y? Is 5 equal to 5? Is x greater than? So the output is booleans. You get false, true, false, false, something like that, right? So this is theoretical. Let's move on. The use of this thing is in the if-else statements. So it says very simple. It says if 5 is greater than 3, you provide this colon in front of the semicolon, or what I get confused between this. You provide this symbol at the end. What happens is, as soon as you press enter, there's an indent. You can see there's an automatic space created. In C++, like you used to use curly braces to enclose the blocks of code. In this, there's a indentation. So it says that if 5 is greater than 3, print this. This indented block will be belonging to this if statement. Okay. If I mention something like this over here, this FHF is not belonging to this if statement. It is belonging to the outside world. Okay. So this is how you create your blocks of code in Python. You provide indentation. It's called indentation or automatic spacing, right? Okay, so this was the bread and butter of Python. You need to know this before you move ahead. Now let's talk about lists. Now we'll be talking about real data storage and analysis. Let's say I have a list where I want to store porosity as a label, and then 0.25 and perm and 50. So this is how you enclose lists. You create a list using a square brackets. Okay. Square brackets. These are the square brackets, and whatever you store inside the list will be stored as a container in the label that you provide on the left hand side. Okay, so now whenever I call or print L1, the values stored inside L1 will get printed. Okay, you can see porosity 0.25, permeability 50, right? So this is list. Now lists are ordered. So for example, this porosity has a location in the list. It is located at zeroth position. This is at first position. This is at second position. This is at third position. If you go from right to left, this is at -1th position. This is at -2th position, and things like that. Okay. So if I try to print, okay, if I comment this out and I try to print L1 -1, okay. Okay, is anyone asking a doubt? Hello?
No, I don't think so.
Okay. Okay then. Yeah, so if I want to print the last element of L1, which should be 50, I can either do this. Okay, let's try this out. Last element is -1, so it takes out 50. Or I can do this. I can do what? 0, 1, 2, 3. Okay, so I can do this L1, 3. Right? So this is what gets printed out. Either way, you're winning, right? So this is called indexing a list. This is called accessing the values of a list using indexes. Okay. Now, what if you want to, print a slice of a list? That is also possible. We'll be covering this. But for now, let's understand a few operations that you can perform on lists. What if you want to add a new value to the end of the list? For example, I want to add this label new rock to the end of the list. You can see L1.append new rock. Okay, so this adds. You can see if I print L1 now, it appends. This appends means adds to the tail of the list, and you can see new rock is now printed. Okay. Now, similarly, if I try to want to count out a particular value, how many times, it can be a lot of cases. For example, For example, you want to count out number of negative values in a list because your square root cannot take negative values, right? So you want to count out something from a list. So this is what is happening. For example, two sandstone labels are there. So I count out rocks.count. It says 2. Okay, brilliant. Now, if I want to reverse, I can do this. If I want to do various things, I can do. If I want to sort, I can do this. Okay, I don't have to, just it's very understandable and self-explanatory. But still, you can go to W3 schools and you can just refer these things. Now, very important, list slicing. Indexing we already discussed. Now we'll talk about list slicing. For example, this is my list. It contains a set of porosities. Okay, 0.10, 20, 30, 40, 50. Now, let's think about the future. If I print this, what should be printed? This should be printed. If I print this, what should be printed? This should be printed. If I print this should be printed. Now, this is important. If I print -2, the index is -2, this should be printed, right? So let's check if our thinking was right. Brilliant. That is what is happening. Just to note, if you are using MATLAB, the MATLAB has starting index as 1. So don't get confused and don't try to bring direct codes from MATLAB into Python. You will get errors. Okay. The first index in Python is 0, and in MATLAB it is 1. Okay. Now I was talking about slicing, right? Okay, let's assume this is a superset. Okay, 1 to 9. Now I want to print the first 5 letters of this superset and call it subset. So I can do it like this. The last element will not be included. 0th index to the 4th index will be printed. Similarly, I can skip. I can hear a few disturbances. Okay, so yeah, if I want to access this similar thing in some other way, I can do this as well. Now, if I want to print everything to the last index but not including the last index, I can do this. So the index, the syntax is the list name, start, stop, step. Okay, step means how many number of steps you want to take forward. So you can start with a particular index, and you can specify the index you want to stop at, and then you can specify the indexes you want to jump. Okay, so the start, stop, and steps will be the indexes in the list. It won't be values, but the indexes in the list. Okay, so and this will be printing out everything in the list. Let's see. Let's correlate our yeah. So superset 0 to 5 prints out 0, 1, 2, 3, 4. You can see 5 is not. Yeah. So superset this also prints the same thing. Now superset this to -1. Prints out everything except the thing which is at -1th index. So it prints out everything. And the last thing is prints out everything, right? So brilliant. Indexing is very important. Slicing is very important because you'll be accessing data. If you're using lists, you'll be using this a lot. Okay. So how do you reverse a list? This is a trick question and practice for you guys. So how do you reverse a list without using a reverse method? Okay. The question is, how do you reverse a list using indexing or slicing? Okay. Brilliant. If you are a C++ user, a lot of people try to, combat and try to say that C++ and Java and all these things are the best. Yes, they may be, but can they beat this? Can they beat these one-liners that Python comes up with? I've worked with C++ as well, but it used to take for loops and long loops to do this. But you can do this in a simple manner in this case. So you can this will print a reversed list. You can see 9876. So explanation is nothing. You're starting from -1, which is the last index. It will be included. Every element is to be printed because you are not specifying the stop index. And then you're taking -1 steps. You're taking negative steps. You're starting from the last and coming backwards. So that is what is happening, and that you can do. Okay, brilliant. The same operations can be applied to strings. When you go back offline and you get this notebook, you can refer to this and try to practice out this thing using strings as well. Because strings are also similar to lists. Just that they store characters and they are enclosed in these quote marks, and they are also ordered. Okay, R is at the 0th location, N is at the -1th location. So pretty similar. Okay, you can see the same code that I applied above is used to reverse a string. You can use this to check if two names are palindromes. You can Google what a palindrome means. Okay. Now we're talking the real game. We're talking about dictionaries. It's an absolute gem of a data structure. It helps store the data with labels like this. Okay, you can see porosity of a rock is 0.25, permeability of a rock is 150, and the lithology is sandstone. It can clear out every detail about a rock. So it's a very informative kind of thing, and this is called the key. This is called the key, and this is called the value. Okay, and it has no order, by the way. You don't say that porosity is located at 0th index or something like that. Porosity is a key, and its value is 0.25. End of the story. Full stop. Okay. It is important because it can be directly converted to data frames. What is a data frame? It is a table in Python. You can directly convert. I'll show you how. Okay. So this is, you can see rock properties. If you try to print out, this is what you get. Okay. Now, what I said is we can directly convert data frames to tables, right? And this is the example of that. For anyone who can understand this, brilliant. So this is my rock data, and this is the dictionary which I was referring to. And this is the data table that I have created using pandas, and this is what is going on, right? So I would like to take a pause right now and just check if everyone could just at least see what I'm trying to display up till now. Can you clarify? Was it visible, guys?
Yes, it's visible.
Yes, sir. Yeah.
Okay, great. So I'll move forward, and will for those who don't understand this, don't worry. It is just a slight introduction to advanced Python guys who are in this meeting. So we'll cover a lot of basics on pandas later, and this is how you can display the dictionary in the form of a table. That's all you need to know for now. You see, porosity is stored in vertical tables. These values are stored in a table format. This is also stored in a table format. And you already get confidence when you look at tables, because tables are the heart of petroleum engineering. Now, iterations. Believe me, the tool with which computer tries to mark its presence is called iterations. Humans can beat computers, and they try to do that, but humans cannot beat the iterative power of computers. You want to calculate something we have no idea about, and the iterations will help you do that. Okay, the two types of what is the iteration? Iteration is something you try to update values, you try to do repetitive tasks a number of times that you specify, you try to loop over and over again, you try to give a condition. Okay, is the condition true? Perform this task, and then come back. Is the condition still true? Perform this task again. Is it still true? Again. By the end of 50 agains, you'll be seeing that your result is well furnished. Okay. There are two kinds of loops. There are for loops and while loops, and both are equally important. And they'll be working with iterables. Iterables are lists, strings, etc. Because you can see that they are collection of items, and you want the loops to work on some kind of ordered arrangement, just using which it will count. Okay, so the first element is still there. I'll work on the loop. The second element is still there. By the time the list gets extinct, I will still keep on working. The very common example is, for example, this is my list. It stores numbers from 1 to 9. For number in my numbers, print num. What is it saying in English is, okay, this is my list. Okay, this is my iterator. Okay, iterable. Now, till you get to pick numbers from this list, print it out for me. By the time you get out of this list, as soon as you get out of this list, get out of this for loop. Okay, this is what I'm trying to say to my computer. So you can see it goes to first position, it prints out the first number. It goes to second position, it prints out the second number. Then it keeps on going. By the time it comes to 9, the next step, when it is at 9, it tries to print 9. Now it is like, okay, let me get out. Is it still there? Is the number still in my numbers? No, I'm in the outside world. So I'll get out of my for loop. So this is how for loops work, or any kind of loops work. If you want to count out the number of values, you can see length. You can use length function, length of my numbers, and perform the repetition of this task, which I specify inside the for loop, till you stop counting. Okay, so I start counting from 0 to the length of my numbers, which is 9. and I try to keep on printing star till my count gets over. Okay, so this is what is happening. 9 stars or 8 stars. Okay, you can see that later. So it is very self-explanatory. You can you are engineers and you can imagine the power of loops. You can, and mind you, this takes, you know, the time that it takes. In Microsoft Teams, it might be taking longer, but on my computer, it is taking very less time. Okay, so now I'll try to run to the practical application of a loop. Okay, this I'll come back to this later. Just to, okay, so this is a practical application for those who are in later stages of their engineering careers. They already know what Newton-Raphson's method is. Okay, they already know. But for those who don't know, just it is a method which helps you find out the roots of an equation. Okay, you have an equation which you cannot. It's not a simple quadratic equation. Your equation is something like x sine x plus x square tan inverse x minus ex equals to 0. Now, can you find out the root using your mathematical brain? You can take time, but you will take time, and time is money. So what Newton-Raphson's method helps you is, you can start with an initial guess of the root, and then you can update the root using this formula, and then you can keep on updating till the root no longer changes. When the root no longer changes, you're already reaching the particular, you know, the minima or the actual value of the root, or the approximate value of the root. Okay, so this is what is, I'm trying to find out the solution of an equation using Newton-Raphson's. It will be approximate, all right, but it will be quick and it will be easy that I cannot perform by hand. The very common example is, for example, I want to calculate the square root of a number using computers, of course. So I'll ask the user for a number. This is how I ask the user for a number. Input statement, brackets, enter the number to be square rooted. What it will do is, it will try to print a square or a rectangle or a space where you can enter your value as soon as I run it, and then whatever value I enter will be taken in the form of a string. Okay, you can convert the string into a float. This is what I've done, because number has to be taken into a float. Float is nothing but a pointed. 5.2 is a float, 5 is a string, 5 is an int, and Divyanshu is a string. Okay, so this is how I take the number, and this is my initial guess. I'll also ask the user if you have any initial guess, and I'll tell you, no matter how stupid the user is, how dumb the initial guess of your square root is, your computer will finally bring you to the correct value. Okay, so I'm using while loops for this. So what I'm doing is, for example, I'll try to form an equation first up, because for Newton-Raphson's you need an equation. So equation is fx equals to x square minus n. Okay, why? Because if you put this equals to 0, fx equals to 0, x square equals to n, which is ultimately x equals to under root of n. So you're trying to find out the square root of n and storing it into x. That is what we want to find out, right? And this is the formula we're using. So while absolute, why absolute? Because we want to, positive errors. So till, okay, of course, the computer will never go to the right hand side to the 0. Okay, you'll never get the approximate or the correct value. But till I get this close to my square root, or till the value gets this close, you know, that if you can see how closely precise I am. So keep running my update statement till this happens. As soon as my error goes below this, stop it, and that's the end of my solution, and print that out. So I'll run it, and you'll get clarity of what I'm saying. Okay, so this says enter the number to be square rooted. You know, say 100, you know the square root of 100. Okay, I press enter. Now it says enter your initial guess of the root. I'll be very dumb and I'll say 50,000. Okay, I think 50,000 is the square root of 100. Now press enter. You can see it still gets me to 10. You want to run it again, you can do it again. You can use it for, let's say, 100. So this is a large number, and I press enter. Now it asks me for my initial guess again. So I say 6. It says, okay, this is my final root. It is brilliant how it computes this even when your guess is so stupid, right? So this is the power of computers, and we'll be using this to check our errors and numerical methods a lot. If you are an engineer and petroleum engineers cover this subject on numerical methods, I advise you to go attend your lectures on numerical methods and come back and try to solve these problems using Python, because it will give you a great clarity about what I'm trying to tell you right now. It's a brilliant subject. It will help you in numerical simulation as well, right? So similarly, we can find out the roots of any transcendental equation using this transcendental equations, the equations like I said, not the uncommon equations, the complex equation, x sine x minus 4 log x plus e to the power x minus x square y or something like that, not y but function of x. So the equations which you cannot manually solve, you can use this method to calculate the root of this. Okay, I've done this and it's a very common example in Tariq Ahmed, Klinkenberg effect. What Klinkenberg effect in petroleum engineering is, it says that I have a core sample. I want to find the permeability of that core sample, and I cannot use a liquid to measure that permeability of the core sample. Permeabilities are measured by flooding the core with a particular fluid. I use a gas because gases they don't try to bother the rock that much, and they give me the permeability easily, and they are inert in a way. They are non-wetting. Okay, but the catch is, the problem is, the permeability that I find using gases is very high. Okay, the permeability, actual permeability might be 25 millidarcy. The gas permeability will be 47 millidarcy. Okay, why this happens is because gases are non-wetting. Of course, they are non-wetting, so they will never they'll try to ignore the rock. They'll never wet the rock. They'll try to just slip away and just get out of the rock and not bother it at all. So this of course means that gases are flowing better than fluids. So we still want to find the gas permeability, and then we want to apply the Klinkenberg correction, which is nothing but a repeated for loop using Newton-Raphson's method, and then we want to reach to the final value of liquid permeability. And this can be covered using an equation which is something 6.9 and something like that, which I don't remember, and it is not important. What is important right now is to remember how to use that equation, iterate over the permeability of gas to ultimately reach to the permeability of a liquid, right? And you can take this back as a part of this presentation at the end. You can take this as a homework. I have worked on this problem, and it is my favorite problem, and this is the link that I'm giving to this problem. And the concept is simple. You can use this while loops. Okay, so let's move ahead. After looping, the very next part which is important is function. For example, what functions help is, functions try to, for example, if you know nothing about programming, you're also using functions in mathematics. A quadratic function, x square plus 2x plus 3. What it is doing is, it is taking the value of x and it is returning fx after applying x square plus 2x plus 3 to it, right? So similarly in Python, what we'll do is, we'll try to take in values, or we'll try to ask the user for input, and we'll try to return something that the user might want repeatedly in his program. For petroleum engineers, and specifically for reservoir engineers, Darcy's law is the heart, right? And you cannot go away without knowing Darcy's law. So what is common in Darcy's law or any radial flow equation or well-test equation is this part, kh by 141.2 mu b and all this. So why not calculate this at the get-go and try to use it again and again in later stages, because this is common. This you will use in well testing as well. This part, this coefficient, you will use in various cases. So I can try to create a function. So what the function does is, it asks the user for all the values that are needed to calculate this. So this is one value, this is another value, h is another value, viscosity is another value, formation volume factor is another value. ln RE by RW, I'm trying to keep it simple, so I'm specifying it 0.5, and I calculate this part and I return it. Okay, so this is the function definition. Right now, if you run it, it won't show any output. Okay, this is just saying that, okay, I have made my function, now bring your values on, I will give the output to you, don't worry. Okay, so next step, what I do is, I try to use the function. Okay, I provide delta p, this is delta p, and this is what I need from my function that I already created. So this is called function execution or the function call. Okay, so it says that whatever is the value this slope function can calculate and returns, try to store it in this m, okay? And then use this m in q equals to m delta p, and then print out the flow rate at this drawdown is this much, okay? So as soon as I run this, so what will happen is the flow of control in Python in the background will be, as soon as this will be executed first, sequential execution. This will be executed first. Now, this will be executed second. As soon as this comes across, the control goes straight away to the previous cell. This gets executed. Return statement gets executed. We come back to this statement. M gets its value from the return statement, and then the next statement gets executed. Q equals to M delta P, and the print statement gets executed. Right? If I try to run it, you can believe me better. So it says that enter permeability. I say my permeability is 150 millidarcies. Then it says enter the thickness of the reservoir rock. I say 30 feet. Then it says enter the viscosity of your fluid. I say 100 centipoise. Then it says enter the formation volume factor. I say 1.015. Okay. And then it says the flow rate at, I provided the delta P. The flow rate at 500 psi drawdown is this much. Okay. Beautiful. So this is how you use functions. In later stages, if you have a code which desires this use again and again, you can do again and again, you can use this statement. You can call this. This is called the calling. You're just summoning the function. Okay, I need you, come here. So this is what you're doing. Okay, you can do this 10 times, 1,000 times. It makes your code look very clean. This is my code. This I won't show to the company man. This I will show to the company man. Okay. And the company man will be like, okay, brilliant, looks clean, I can understand it. And that's what you need. This is called abstraction. Abstraction, hiding the unnecessary part of the code and just displaying the relevant information, right? Okay. So this is something that we already did, and this is something, and I guess this is all about the basics of Python that you'll be needing as a part of this reservoir simulation and developing your Python models in oil and gas. You have a lot of knowledge already. You can go back and you can develop you can solve petroleum engineering problems. I'll try to take you to a tour of what this notebook will have for you. We'll be talking about NumPy in the coming sessions. We'll be talking about various functions that will help you create saturations. It will help you create permeability vectors, and it will help you create a lot of things. I'm providing links as well. You want to convert your Python base into a scientific calculator. You can do that as well. You can apply trigonometry. Then you can form tables as well. You can see this is my brilliant table. I can toggle around, and I can import external data files also. I can work with them. Don't get intimidated. I'm just giving you a tour so that you know what's coming ahead of you. And this is some data set that I'm just using just to explain you various things. So I'll be covering it. And the most important part that I want to show you is coming later on. It's exciting. It's really exciting. Yeah. It clears the story, period. It clears the story. So we'll be covering visualization, starting with the parabola. Then we'll be covering customizations, how to make your look pretty, very pretty. So this is something that you can do. And then oil and gas examples. And this is, wow, this is brilliant. You can develop your own relative permeability curves, and you can show, and you can post things on, and you can create your own CV using petroleum engineering problems. Okay, so this is what is coming ahead of you, and I'm very excited, and I guess this is it for today. I would like to take any questions and help you understand better. Okay, this is all from my side for today. Do you have any questions?
No, sir.
We don't have any questions.
Just a doubt. Hello?
Yes. Yes, yes.
You told about data frames, right? So while handling data frames, is it only possible for dictionaries, or let's say we have two lists also, we can do that for data frames?
Yes, you can do that. Your good name?
Arindam here.
Okay, great. So this is how I'll in fact show it to you in this. Actually, in the dictionary example, I was actually using the lists, just that the label was there. Otherwise, you can use two lists and create different columns of the table. There's no problem to that. You can add new columns to your pandas data frame. Actually, data frame, I'll cover more about it later. And this is just basic. How can you can directly convert from a dictionary to a, but it is possible. Yes, you can create lists.
Thank you.
Yeah, welcome.
Hello?
You can ask me anything. Yeah.
I have a question, please.
Sure. Your name?
You can call me Abdul.
Oh, hi, Abdul. Yeah.
Okay.
Please go ahead.
Hi, sir. I just wanted to ask if you're gonna represent an approach for reservoir simulation case study rather
Yes,
than
definitely.
the Python coding. I just want to know how would you apply actual data or actual case study using your source code.
Yes. So to that, I would like to say that I'll be explaining the background of what goes on. If you go and check CMG, for example, what you will see is it asks for a lot of inputs and then it tries to show outputs and the effects of various things that you tweak around in your simulator. So I will try to build a simulator myself from the very scratch. I will try to describe mathematics about how equations can be used to develop the simulator, which are actually I attended a training, and that is the base in all the commercial simulators. So you will know how you should think about when you're using CMG and how you can develop the same plots that CMG builds up. You can develop your same conclusions using Python as well. So yes, we'll be covering a good deal about reservoir simulation.
Okay, thank you, sir.
Thank you. You're welcome.
Hello, sir.
Yes. Hello.
Sir, can you explain me about that Boolean? How it is applied?
Yes. So your name?
Salman, sir. Salman.
Okay. Hi, Salman. Okay. So Booleans are nothing but true false kind of things, and we try to run inequalities or equalities. So these are three things that I'll write in front of you. Okay. So this is okay. I'll try to comment it first. So using this that you see, double equals to sign, you try to check if left hand side and right hand side are equal to each other. So if it is equal, the statement gets executed and you get printed out as the true or false, whatever is valid, right? And then you can see this, then you can see this, then you can see x is less than y, things like these. And the output of these things are Booleans. Booleans are nothing but true, false, the truth statement. Is it true or is it false? Right. I hope I could answer.
Sir, if we put that in the double quotes or single quotes, it is mentioned as string or as integer?
In strings, you can enclose strings in double quotes as well as single quotes. Both are interpreted as strings. But if you want to convert a string into an integer, you can do that using the int command or something. You can press int. I'll show you. You can do this. So for example, this is my code. I have a string. I have number stored in the form of a string. This is my number, but I want it to be 5. Okay. So I will try to store it like this. Okay. Number as int 5. Now if I run it, what will happen? Now if I check the type of, you can check the type anytime. You can, if I check the type of number, you can see the type is int. So is it clear? So you can always typecast. This is called typecasting. You can have strings and you can convert them into numbers.
Okay, sir. Thank you.
Hello, sir.
You're welcome. Yes. Hello.
Sir, you talked about visualizations in Python. So I had a doubt that we can do visualization in Excel also. So what difference does it makes in Python and in contrast to Excel? Can you say something about it?
I would never, what do you say? I would never say bad things about Microsoft Excel because it's my favorite place as well. But the good part about Python-based visualizations is that it offers you a lot of customization. First point, it offers you a lot of different modes of printing. Whereas in Excel, there is a template which you have to use, and that is one thing. The second thing is there are libraries in Python which you can use for interactive visualizations, and you can do 3D visualizations and a lot of these things, and also the commands that you enter. For example, in Python, if you remember, and if everyone can recall, you have to select data sheets and all these things, and it's not that clear. You have to do multiple attempts. At times you create errors, but in Python it is very easy to set customizations. Very easy. You rarely make errors once you get comfortable. But in Excel, it's still not user friendly. So that is how I would like to conclude with that.
Okay, sir.
Hello, sir.
Hello.
This is Frinjoy. I was wondering if you can explain to us how Python is going to be useful in well testing. Like how can it be using with real-time pressure time data, and how can you do those plotting things and calculate those permeability and like skin factor?
Yes.
Will it be helpful if you can just explain to us?
It is definitely helpful. I have recently worked on a pressure drawdown test as well as pressure buildup test to actually plot, log plots. It's nothing but you have a pressure versus time table. Okay, you might have that on Excel or anything. Pandas in Pandas library, it allows you to import that data into Python like this data set. Right now, I can perform manipulations. Okay, I can perform manipulations. I can form T del P by del T, the table T del P by del T, and I can also perform the log of time, and I can do various log plottings, and I can visually find out the horizontal plateau that I get in my log plot. So I will, if you are interested, you can go and check my GitHub repository, or you can personally mail me. I'll send you the code and I'll explain you this so that you will understand this better. Right, I have worked on it.
Definitely, sir.
Hello, sir.
Great. Hello.
Sir, can you put some light on how we can use real-time data using Python?
I can ask around. I have not actually worked with real-time data. Yeah, so I can. There is if I'm not wrong, there's online learning. If you want to apply machine learning models, there's an online learning section where you can just keep on having data inside your model, and the machine learning model will try to update itself. But if you want to discuss it again, like to just keep it to the task of presentation, we can discuss this thing. I can also search around. I don't know. I have not worked on it.
Okay. Thank you, sir.
You're welcome.
Sir.
Hello.
No, sir. Prepare this side.
I heard a sound.
Hello.
Yes. Can you be? Yeah. Hello.
Hello, sir. Sir, Kritika this side. Sir, I want to know about as we are interpreting our data using Petrel porosity and permeability logs, can we interpret the logs using Python?
Definitely we can. Definitely. First up, we can visualize it to just get a feel of what the data is. And I suppose you are saying you have a data set in your hands, right? So you can you visualize it, and you can try to find out correlations. I'm working on one data set. It is available on Kaggle. So very popular data set. So Kaggle, guys, is a place where you can practice and data sets. You can get data sets. Yes. So I would like to say we can work on this. I started a project. I've completed the visualization, and I would like to say that yes, a lot of conclusions can be made. You can develop correlations between various parameters. You can develop K-phi transforms using these data sets. If the permeability, you can try to interpret you predict various things using machine learning, given the data set is large enough, and you can do a lot of things. Basically, you can do a lot of things if in logging. because the data is huge, right? So yes, I can come back to this question later when I have something ready. Okay.
Thank you.
You're welcome. So do we have any more questions?
Sir, can we use this Python in geology?
Of course, if you have a data set from geology, of course, I am not from a geology background. If you have a data set from geology background, please let me know, and I can try my hands on, and we can try to understand what we can do in geology using Python. Python is open to every kind of project there is in the world. So just you need is a data set. Otherwise, you don't even need a great computer. You can import things into this place, the folder shown over here, and then you can take it into your Python code and you can apply manipulations. You'll get a bit more clarity as I cover pandas section. You'll get a lot of things, ideas that you can do with your data. So sure, you can do it.
Sir, as you have large chunk of data, so how do you train and then you test your models that you prepare? Do you have any thumb rule for that or something?
So the large set of data, the first time you get the data, the problem is the data will not be available to use directly. You'll have a lot of voids in the data, a lot of null values, a lot of places where porosity will be negative, a lot of places where permeability will be 60,000. So a lot of places you have to, pre-process your data. So that you can do by, for example, you can plot trends in the data, you can remove outliers in the data. The first process in data analysis is pre-processing. You work with pre-processing. And then once your data is ready to use, then you split the data into two parts. One part you use for developing a model, the other part you keep, absolutely inert. You don't touch it. You keep it separate. So the part that you are developing your model on, you build a model, say regression, you say a predictor model, you build a predictor model, and then you try to validate or try to check how good the model is doing with the second part of your data. And then you say your machine learning model is good or bad. So this is the answer to your question.
Okay, sir. And how do you choose which feature would you choose in order to predict what you want? Is there will be lots of features in the data set, right? So
yes. So good question. There are two parts. There is feature engineering, and then there is feature importance or feature selection at the end. So feature engineering is where you have no idea which feature is important, and you want to check which feature is important. Feature, by the way, for everyone, feature is nothing but in the table. For example, I show you the table. The longitude, latitude, housing median, the labels. These things are features. Okay. So my model will be like, okay, why are you giving me latitude, longitude, man? I don't need it. So I am already, my model does not want this because it's trying to predict something which has no use of this. So this is feature engineering, intuition. You have to find out the features that are the columns that are not important to your data. So first thing is the feature engineering. The very important thing that you can do is, for example, one column is X, the second column is X square. So both these things are mathematically identical to each other. Both these things will show a 90% R square positive correlation. So you can check for R square value or the correlation between the two parameters. If you think they are very correlated to each other, you can use either one of these, because that will give you using two features will add to memory cost as well as computational cost. So there are other nuances you can do in feature engineering, and you can check for. I hope I gave you a clue.
Yeah, sir, I have been following you in LinkedIn, so you have been motivating me for a long period of time towards Python and machine learning and all. Sir, where do you get all the data sets for preparing the model? Can you repeat it again? I didn't get you.
This is my favorite question that I wanted to cover this. I have had this question from a lot of people. Actually, I would suggest at the start, if you are trying to build a base for Python, you don't need data sets. The data sets are there in your books. You can open up any book. You can open a Kermit Brown. You will get a data you can apply machine learning on. That huge data. So you have your data in your books to develop algorithms on. You develop your mind map on those data. That is what I do, and it helps a lot because you already know the
Sir,
answer. So you can, yes, hello.
so one question is that, sir, likewise in reservoir simulation, we are using Python language. Another in drilling and automation, drilling automation, sir, can we use this Python language?
Yes, a lot of people are trying to do that. So I'll come to this question after I cover the previous question, if that's fine. Right? So someone was asking me about where to get the data from. So first, I will try to answer that. Right. So the data, first up, if you are new to Python, you just open up LP if for reservoir engineering, Tariq Ahmed and various books, and you find out data they have in their problems. Well test data is there, some data is also there. So you can practice and develop a mind map. Then there are sources. Valve data I've never used. So there's Equinor's Valve data. I guess a lot of people from PDPU have the access to that data. You can contact them. And then there are new websites called Data World, I guess. Data World. I'll send you the link if you contact me later. Data World. Then there is logging data on Kaggle also. You can search for just brainstorm and search on GitHub also. You can get a lot of things on GitHub. Or what you can do is you can try to get the data. Some papers also give the data outside. So you can go to one Petro and get data as well. So these are a few sources. Good enough for practice. Yeah.
Okay, sir. I shall try to contact you in LinkedIn. So
Sure.
my name is Vishal Gupta from Dibrugarh University. So it was nice meeting you.
Great. Please contact me. Okay. Yes. So coming to the next question about drilling automation. I have, to be honest, I've never worked with drilling data per se, and automation is still a long way ahead of me. But yes, if you want, I can try to talk to people. I know people who are working on this, so they will be better ones to answer this question. So please contact me if you want to discuss further, right? So, any more questions?
Hello, sir. Hello. Could you give a brief summary or an overview of how you can achieve reservoir simulation using Python?
Sure. Good question. So it will be a good teaser for tomorrow or the day after tomorrow session where I'll be covering this in details. So basically, I'll give you a slight mind map. What's happening is you will be getting introduced to a partial differential equation first up. That will be the base, and that is the God, and that is heart. So you'll get to know how to solve the partial differential equation using numerical methods, using your notebooks or the copy and pen. Then we will come back to solving the numerical simulation in Python. And we'll try to simulate cases like we'll try to find out how a presence of an aquifer, people might already know, the presence of aquifer, it tries to develop a pressure response different than the presence of a no flow boundary, right? So this is how you can develop intuitions at the starting. But the base is very easy. First, you will find the type of differential equation that the whole reservoir is based on. So that is based on EOR cases will probably have different equations that they use, but normal reservoir engineers, they use the diffusivity equation. Then we try to find out how we code the diffusivity equation into our computer programs, and then we try to generate data sets out of our simulations, and then we get back to the field data that the similar reservoir is giving us. And this process at the end is known as history matching, where we try to validate how close we were to the predictions made by the field. Right. So this is what we will be covering in the reservoir simulation section. This is just a slight overview. Okay.
Thank you, sir.
You're welcome.
Hello, sir. Sanskar here.
Oh, Sanskar, hello.
Sir, can you just repeat the work of F function that you generally use in your codes?
Sure. I'll go to that right away. So F string is a formatted string. So for example, if I want to print a variable I've already declared. I've already said that X is equals to 5. Now I want it to print in a statement which says that, hello guys, the value of x is equals to 5. Okay, one way is you can explicitly type it, the value of x is FIVE, but that will mean that even if you change the value of x, your FIVE will stay FIVE, right? So what do you do in that case is you try to, I'll build a code separately. What you can try is you can say P equals to 800, okay, for example, pressure. So I'll do both the print statements and you will understand the thing yourself, okay, without the F statement and with the F statement, okay. So let's see.
So this is without F statement.
Yes, this is without F statement. And in the next line, I will print with F statement. So you'll see the difference.
Sure.
So yeah. So you see the difference? If I don't use F statement, there is no, Python gets dumb. It does not understand what I want. But when I give F statement, Python is like, okay, I know what you want. I know what you mean when you give me this. I know what you're trying to tell me. You're trying to tell me that wherever I see curly braces, you want me to take it as a placeholder. And the placeholder will hold the value of P rather than the picture of P exactly, right? So it holds the value of P, that is 800, takes it from here and prints it here. In this case, it thinks this is what I want to print. In this case, it thinks this is what I want to print, right? Is it clear?
Yes, sir.
Okay, great.
Sir.
Hello.
Hello.
Sir, does this F means both it just implying to hold the value?
Yes, the F means you are trying to tell Python that wherever you see something in curly braces, treat it as a variable which already has a value. So it will try to take that value rather than just thinking of it as a string. You can see the color also changes. That's a good idea of it. You can see it changes to white. In this case, whatever is a string will be an orangish color. And in this, you can see it is in whitish color. Whatever is whitish, it is numerical. It has a value, right?
Sir.
Yes.
So one more question, sir. Through this, can we enumerate the flow rate data through Python programming in reservoir simulation?
I'm not sure your question was clear. Can you please repeat?
Sir, what can we can we manage the data of flow rate through this Python programming?
Flow rate. Data
Yes,
of flow rate. Yes, we can work with, if you want to, still if you want to calculate flow rate. Is that what you're asking?
Yeah.
Yeah, I gave you an example, right? You can calculate flow rates in various cases. I have also built the code in my early days where I calculated flow rates in a case where my skin was huge. Then I tried to lower my skin to a lower value and I saw that my flow rate increased. So yes, you can do that. You're just applying the radial Darcy's law in various cases, and you can get the flow rate out using Python. If you want a link, I can share it with you, so you can contact me and I can share you exactly what you're trying to ask me. Okay, so.
Also, is Python programming is used in Kappa engineering, sir? Kappa software.
I think Kappa is for well test analysis, right? And Kappa, the programs that are, I won't say much about this, given that I've not used Kappa, but there's my senior, he's Shantanu sir, he's giving trainings on Kappa. But what I can say is the well test analysis part can be pretty well covered using even Microsoft Excel as well as Python. However, the benefits in these commercial softwares lie in the fact that they give you buttons, right? They give you buttons, then you can just click on buttons and then you can calculate. But the background, all you can do in Python, basically. So I will give you data and I'll tell you to do this. You can find out permeability. just using pressure and time data.
So my project, I'm just getting pass out. So sir, can I make a project on how we implement Python programming in reservoir simulation? Is a good topic, sir?
Sure, sure, you can do that. That's what I'm trying to convey in this presentation. You can contact me. I'll try to whatever I'm learning, I will share with you. You can develop your
So you are
final year project.
yes, sir. So are you on LinkedIn?
Yes, I am on LinkedIn. My name is
Your name,
Divyanshu
sir?
Vyas.
Okay, sir.
Divyanshu Vyas. Yes, yes.
Divyansh. Yes. Okay, sir. Thank you, sir.
Okay. You're welcome.
Hello, sir. Sir.
Hello. Yes.
Yes, sir. I am Dev, sir. Sir, I want to ask that is it necessary to know Python or any other coding language in order to learn Petroleum software, sir?
Not exactly, but you know what will happen is you need to know the math that goes behind. And once you start doing the math, and you'll realize that the computations are really hectic at the end. The computations are hectic, and for example, a software is trying to simulate a 100 by 100 grid of a reservoir. Can you do that by hand? Yes, you can understand how you do it by hand, but since you have understood it, why not develop a model? Why not try to tell to the world, okay, you can also do this. So that is the advantage. But you can, if you hate programming, you can basically go for mathematics, and it's pretty fine as well.
Okay, sir. Thank you, sir.
You're welcome.
Hello, sir. Vishal here again. Sir, can you throw some light on the importance of dry run of the programs that we will be doing? As means trying out the programs with pen and paper before trying it on the laptops. So,
I could not. Can you please repeat the question? It would be better.
yes, learning programming language is not so easy. So, how did you begin learning it? It will help us in our process of learning also. Your story of programming.
Yes. So yeah, I agree with your point. Initially, it's a daunting task. You feel like, what is this, and why is this square bracket coming on, and various things. So I can guide you to sources. You can learn these things from. There are a lot of things available on YouTube, and you can use this. Actually, you will never learn it totally. You'll never learn it all. It's good to have a reference in back of your mind and try to copy. Copying is fine. It's not an exam. Initially, you will try to develop your codes using copy paste. But at the end, you will try to learn the workflow, and then you will develop your force automatically. So don't worry about getting stuck initially. You can do it. Don't worry. Right?
Sir, this coding, sir.
Yes.
Sir, this coding has become what would it is like some broad we can't able to understand, right? So how what any key role any key points to understand this key point this coding while we implement
coding.
Yeah,
yes,
we
yes.
are.
Yes. So if you are absolutely zero in coding, what you can do is, for example, if you come across a dictionary, okay, try to correlate it with what a real dictionary is. You think about dictionary, and the dictionary has words and its meanings, right? And something similar is happening in this also. I have porosity and its value. So Python is brilliant because if you start learning C++, I don't guarantee you that you will be a perfect master in it. But if you start Python today, by the end of this week, you'll send me your particular models yourself. You will be that great in programming. So Python is very easy if you start it. And if you get stuck, again, like I have said this 10 times, you can contact me. I can explain you at any level without using the jargons or the tough words. And you can get great at Python. Don't worry.
Thank you, sir.
Hello, sir.
Hello.
Yeah, good evening, sir. So, I wanted to, if you could please just shed some light on any application of machine learning or deep learning during simulation.
Yes.
I wanted to.
Yes, yes.
Yes, sir.
Yeah, so are you like comfortable with? Okay, so I'll try to explain you. For example, for reference of what I'm speaking right now, you can go and check the project that I've done on simulation, water drive simulation right now. I've generated a data set. Okay. Now the end goal of a simulation is you have to make sure that your simulation model is actually representative of the actual reservoir, right? That is the end goal. Otherwise, it is of no use. You cannot use the reservoir simulation. The task of a reservoir simulator is to give you the foresight in the future. For example, I have two options in EOR methods. Either I can go with polymer flooding or thermal flooding, right? Thermal stimulation. Now, I don't know about my reservoir, so I will put these options into my simulator. My simulator will give me what do you say, a recovery factor for both of these cases. And the one case which has a higher recovery factor, I will go with that. Without even touching my reservoir, I could make a decision. That is the task of a reservoir simulator. Now, to achieve this task, what we do is we try to generate outputs from a simulator which we already have from the field, right? From that particular reservoir of which we are making a simulation. Now we have to try to achieve a history match between these two data sets. The outputs that the field is giving, which is the actual output, and the output that the simulation is giving. But if both of these guys are very far away from each other, I cannot use my simulation model. So what I will do is I will try to use my machine learning algorithms. I'll try to minimize the error between these two guys by tweaking around, by changing the porosity values that I use in my model, and I can use gradient descent to minimize the error. If you know gradient descent, I have variable options in machine learning of which I can use. So this is one example. We can minimize the error and reach a history match quicker. This is my imagination, but there can be a lot more. As we go along, we can discuss a lot more examples.
Okay, sir.
So, any more questions?
Sir, the commercial simulators, do you know what language are they coded in?
Yes. So, Eclipse is coded in Fortran, Fortran, Fortran. It was an old language, old because by the time I was there, Fortran wasn't there. So Eclipse is based on Fortran language, and Fortran is very fast, and Eclipse is still using the version. It is based on Fortran language. So other than Eclipse, I still don't know what CMG is based on, but yeah, you can find that out. But every simulator has a coding language. Period.
So
yes.
So what? So this Python programming is useful in T Navigator.
Sorry, can you please repeat? In what?
So can we implement Python programming in T Navigator software?
T Navigator.
Yes, sir.
I'm not sure I've heard this term before, so I'm not the best person to answer. No, I've never had a chance to work on that, so I won't be able to say. But you can try that out.
Intersect line, sir.
What?
Intersect line was Lumberger.
Yes, intersect. Yeah, intersect is based on Python. So their workflow is not basically, no one reveals their workflow, but they allow us to do open source manipulations. Intersect is a new venture by Schlumberger in which we can do open source manipulations using Python. So we can collaborate Python with the Reservoir Simulator. And there are a lot of ventures coming up which apply machine learning to reservoir simulation, water flooding management. There's one from ISM's alumnus. It's called Tachus, TACHYUS. It says that it can simulate a water flood management in 5 minutes using machine learning approaches. So I wanted to attend its webinar, but it's brilliant. The world is shifting towards these things as well. So yes, we can do it.
So that Tachus is made by ISM.
ISM alumnus. He's someone from a good team. Basically, I have no detail, but yeah, someone from ISM went ahead and yes.
It's a local guy from that place. That's right.
Yeah.
So, can I move forward?
Okay.
Thank you so much, sir. I would like to thank everyone for their patience. It was a very interesting session. Thank you so much for your time. Now, link for a feedback form is dropped in the chat box. It's compulsory for everyone to fill this form as attendance will be counted based on your entry in this. Now, the next session will be resuming tomorrow. Thank you, everyone. We can all leave the session now. Today's session is now officially over.
Great. Thanks a
Excuse
lot.
me, ma'am, just a minute.
Hmm.
Yeah. If you're accessing by phone or tablet, I don't think we can easily access the chat box. So, how do we fill the feedback form?
If you have a, who am I talking to? Who am I talking to?
Arindam here.
Okay, if you're having a problem, we'll be mailing you the feedback form. If there's anyone else, they can speak up so that we can personally contact you.
I'm also facing the same problem. I cannot
Who am I talking to again? Raj.
my name is Raj Krishna Sekhe.
Okay, noted.
Ma'am, can't we create a group, separate group for in WhatsApp?
I'm not sure if we do we have your phone numbers, everyone's? Nehal, do we have everyone's phone number?
Yeah, I do have in my database. So those who are facing problem, just tell me your name and I will mail you regarding the same.
It's Salman here.
Hello.
I'm facing same problem.
Okay.
Hello,
Actually,
it's Pooja Kumari Sinha. Actually, I'm
Mhm.
facing the same problem.
Okay, we will look up to this problem. I think we should make a WhatsApp
Hello,
group.
ma'am. Ma'am, there is not any option for chat box. That's why we are facing.
Okay, no problem. I think we'll make a WhatsApp group since we have all your numbers.
Okay, ma'am.
Is that
Yeah,
fine?
it's better, sir. It's better, ma'am.
Okay.
Okay, thanks a lot.
Working, I guess. Only the chat box is disabled for us.
Can we leave a group now?
Yes. Everyone can now leave. The session is now over. Thank you.
Okay.
Thank
you.
Hello, is it audible there?
Yes, it's audible.
Yeah, I would like to ask, since I joined this session a bit late, can we get a recorded version of this something on our mail or something? Because I missed some.
Nehal, can we do that? I think you have
Yeah,
started.
I will mail you the YouTube channel link, and wherein you can get the access regarding the same of each and every lecture.
We have a YouTube channel, FIPI PDPU. If you go to the YouTube and search FIPI PDPU, you can find the session there. So whatever that you think you have missed, or even if you want to revise, you can go and check up the video. We are in fact live right now, so we'll be uploading this too on the YouTube channel.
Thank you so much. Thank you so much.
No problem.
Okay, thank you guys. Thank you, Setu. Thank you, FIPI, PDPU. Let's see you tomorrow. Thanks a lot.
Okay.
Bye.
Thank you, sir.
Oh, welcome.
Thank you, sir.
Thank you. Okay, bye.
Okay, bye.